welcome back to some more geometry fun. We're talking about inductive reasoning and conjectures. All right, so let's talk about inductive reasoning. Let's just dissect the word inductive. What do you think? Inductive. In. It's like you're adding something in. It's a good way to remember you're adding something in. So inductive reasoning is reasoning, using kind of common sense of things. You're reasoning by using a certain number of examples to make a conclusion. So you're adding a bunch of examples like, well, this is true, this is true, this is true. Then I'm assuming that this is true for all possible things. So the conclusion is probably true, but not necessarily true. So the concluding statement that you make using the inductive reasoning is called conjecture. You're making a conjecture to what's going on. So for example here, it says Jennifer leaves school at 7 a.m. Fix that. There we go. Looks a little odd. Move that over. All right. Jennifer leaves for school at 7 a.m. Jennifer is always on time. So Jennifer conjectures that she will always be on time if she leaves at 7 a.m. Is that probably true? Yeah, but can it not be true? Also, yes. What could happen to Jennifer on the way to school? She could be hit. She could get a flat tire. She could die. Who knows? There's other things that could possibly make that not true. But assuming everything goes to plan every single time, Jennifer will always be on time if she leaves at 7 a.m. That's her conclusion, that she will always be on time. This other one right here, hey, so you're in somebody's house, say, hey, the chair in their living room is red. Well, the chair in their dining room is red. So I'm going to just make the assumption, the conjecture, the chair in the bedroom is red. Okay, we can make assumptions. We can also then say, hey, if the chair in the bedroom is red, they could also then just assume all chairs in their house is red. Could it be true? Yeah, but doesn't mean it's necessarily true. They could have a brown chair in their house. Who knows? You don't know. But that is conjectures. That's inductive reasoning. You're noticing a pattern and making assumptions. When we're doing math, lots of the things we do is pattern based. So we can usually make a conjecture based on the pattern we're recognizing and mostly be true. Sometimes there's exception to those rules. So be aware though, sometimes all it takes is for one example to make a whole statement false. It's called counterexample. So we're going to write counterexample for lots of these right here. So true or false, all prime numbers are odd. Well, think of prime numbers. 3, or prime numbers would be 1, 3, what else is a prime number? 5, 7, 11, 13. Well, they all look odd, so that might be true, but we're forgetting one specific prime number right here, a 2. A 2 is a prime number, and it's not odd, so the counterexample is, this would be false. 2 is even and prime. That would be our counterexample. So as you're going through your homework, I'm going to ask you to write some counterexamples. You'll write it in best of a sentence you can. All current American dollar bills are green / bluish. True, but there's one example of not. It's actually a false statement. Why? The $10 bill is what color, y'all? It's tan. It's tan. It's kind of tannish looking, brownish, tannish. All freshmen are cheaters. Most of you guys will say probably true, but that is false. All it takes is one freshman to not be a cheater. One freshman is not a cheater. All birds have wings. True or false? Cover your question. That is true. To be a bird, you have to have wings. That's kind of one of the classifications of birds. There's other things to be a bird, but wings is one of them. Yes, even penguins, they're birds. They may not be able to fly, but they have wings. All right, so a couple more examples to look at this right here. So Gabriel started training with the track team 5 weeks ago. During the first week, he ran 0.5 miles at practice. The next 3 weeks, he ran 0.75, 1, 1.25. If he continues this pattern, how many miles will he be running at the end of week 7? So what are we assuming that's happening? That he's increasing half a mile every week. So week 1, it was 0.5, 2, oh, 0.25, sorry, he's raising a quarter of a mile every time. So week 2, he's at 0.75. 3, he's at 1. 4, he's at 1.5. 1.25, sorry. So that means week 5, we can go ahead and assume he'll be at 1.5. In week 6, he'll be at 1.75. And week 7, he'll be at 2 miles. Okay. So according to this, how many miles will he be running each practice during the 7th week? 2 miles. We can make that conjecture right there. All right. Other types of conjectures you'll have to make throughout the homework. Hey, the product of two odd numbers. What is the product of two odd numbers? So they're asking you, hey, product means multiply. If I multiply two odd numbers, what will always happen? Well, let's take some examples. 3 times 3. What do we get? 9. 5 times 5, 25. 1 times 1, 1. What's another odd number? 7 times 7, 49. What's special about 1, 9, 25, and 49? What do they all have in common besides being perfect squares? Actually, let's take non-perfect squares. Let's take 7 times 3, get 21. 5 times 3, get 15. What did all 6 of these numbers have in common? They are all odd numbers as well. So the product of two odd numbers are odd numbers. They're all odd numbers as well. That can be your conjecture here. Okay, the relationship between the area of a square and the side x of a rectangle is x and 2x. Okay, so what can we assume? The relationship between the area of a square of a side and a rectangle with side x and x2. So what's special about the area of the square? A square and a rectangle. So the square is x and the rectangle is x and 2x. So let's look at that. So what would be the area of a square? If the side's x, it would be x times x squared. What would be the area of a rectangle if one side's x and 2x? Well, what's x times 2x? We get 2x squared. So we could say the rectangle is twice the size. Twice the size. Because it's 2 times bigger size. X squared and 2x squared is twice the size. That's it. It's not as hard as it seems. This is the part of geometry where we stop looking at numbers and shapes and start looking at ideas, and we start creating ideas. We're finally opening our mind to something, a different level of thinking, a different style of thinking. So we'll take our time doing this. Y'all have a great day. If you have any questions, let me know. Bye.